last lecture, we started with chapter 1, and we discussed what's meant by differential equation, the two types, ordinary and partial differential equations. Then we said that we are concerned about ordinary differential equation. And how did we classify ordinary differential equation based on what? That we have derivatives, ordinary derivatives, but we talked about linearity and order. How do we determine the order? The highest derivative. Okay, so if the highest derivative is y prime, we will say that it is first order. Then we talk about linearity. What do we mean by linear ordinary differential equation? Do we care about x, the independent variable, or just the dependent variable? The y prime, y double prime. What should be the power of them, Johnny? In linear. 1. Okay, then we talked about solution. So how do we determine whether a certain function is a solution or not? Substitute it. And while substituting it, what may we mean? Like equal, right? We may need also to do derivatives, right? Okay. And after the solution, we will talk about initial value problem. So what's basically an initial value problem? A differential equation, and what does it have? Initial conditions, right? If we have a first order differential equation, how many initial conditions do we need? 1. Why? Because we have something known as family of solution, right? And the family should be dependent on parameters, and the number of parameters will be according to the order of the differential equation. We can imagine it like we have integral. The more integral sign that we have, the more constants we need to find. So the more initial values we should have. Okay, coming from the initial value problem, and we said that our main problems in differential equation or in any model that we have, when we model it using a differential equation, whether it's ordinary or partial, we have 2 questions to ask. First of all, does the solution of the problem exist? If it doesn't exist, it doesn't make sense. I will move and check if I can model it with another stage. If the solution exists and it has, let's say, 100 solutions or 200 solutions, it doesn't also make sense. So what do I care about the solution to be? Unique solution. Last lecture, we said that we are involved, we care about the types of order differential equation, which is first order, to know whether the solution is unique or not. So any first order initial value problem, how can we write it, Miss? We can have it in this way, right? Y prime equal a function in x and y x naught equal 5. We characterize this one. When can we say that it has a unique solution? Now, what we will do during today's lecture, first we will continue talking about this part. Then we will move from 1.2 to chapter 2. We will start by solving first order differential equation. We'll start with. Now, the good thing about chapter 2 is that each section, it has a specific shape, and you will learn this shape, how to solve it. So we will talk about separable function, method of separation. If we have enough time, we'll talk about linear differential equation, how to solve it with constant options. Okay, so we have this one, first order differential equation with initial value problem. So here we have an initial value problem that is first order. We can write y prime equal, when we say f of x, y, it means that I'm writing y prime equal x plus 1, for example. Y prime equal x squared times 1, and so on. Okay, and how many initial conditions do I need? Y x naught, let's say I will call it y naught or y a equal 2. Our aim here is to check if this one has a unique solution. All what we need to do is to check if it has a unique solution, we will check F is continuous. Okay, it should be continuous in an interval containing. Why? Because the initial condition is based on F. Oh. Is this one enough? So this is the first case. I will check F. So for example, if I have F1 over X, and I'm giving the initial condition as Fy of 0, can I use this one? It's not continuous X. Okay, the second thing, I will go and find Fy. Fy also, it should be continuous and an interval containing what's this Fy guys? What do we mean by this Fy?
Partial differential.
This one we can write it as del Fy del. I'll say the same that this is partial derivatives because he took already calculus 3, so we know the idea of partial derivatives. For those who did not take before, calculus 3, I think that in some of your physics courses or engineering courses, you have this notation, right? If not, that's okay, we can explain. So this when we have a function in more than one variable, when we say x, this one, it means that we are differentiating with respect to x, okay? Differentiating with respect to x, it means that we deal with y as what? As a constant, like a number 2. So if y is alone, the derivative of it will be what? 0. And if y is multiplied by a function in x, I will just copy it. Does it make sense? No? Okay. Let's look at this one. F of xy equals x minus 1. We want to find f(x). Derivative of f with respect to x. X, it becomes 1. Minus y squared with respect to x. Right? So it becomes 5. If you look at this one, g of xy equals x squared 1. Now, y, what do we need to do? Deal with what as constant? Deal with x as constant. Again, means that if x is alone, the derivative of it will be 0. If it's multiplied by a function in y, you will copy it this way. Okay? What I need from you to do is to write in front of you f equal x squared y. Please write f equal x squared y and find x and fy just to make sure that we understood. X squared y. So we have g of xy equal x squared y. We need to find g of 1. G of 1. This one is what? Constant, right? Constant times y. The constant times 1, right? And inside this constant, I will copy it again. Famous. So whenever you are, let's say, I'm differentiating with respect to x, but instead of the y, cover the y by an apple or something, just to remind yourself that it's a constant. Let's say that I have here plus y. So this is an apple here. The apple here, it becomes 1 because it's alone 0. Suppose that I don't have y. I have, instead of y, I have e power y. Also, it's not just in y. So I will make it as what? As I said, ex. Because here x is the constant. So ex also, it becomes what? 0. Any questions? Why do we need partial derivatives now? We will go back to this one. We have this infinite problem. And to check if it has a unique solution over an interval containing x naught, we need to check that f is continuous. When we say continuous, it means that it doesn't have. We'll give you an example. If we have, let's say, 1 over x, can I say that it's continuous at x equals 0? Okay. If I have radical x, can I say that it's continuous at -1? Because it doesn't exist. Len x, is it continuous at 0? Len x, is it continuous at 0? Why? It doesn't exist as one. So it means that the function doesn't have problem at this point. Do we have any questions, Miss?
The first one's supposed to be f x.
Why? No, this one f. The function in general, the function that is given, and the second one fy. This is the rule is here. You will find f and then fy. Do we have any questions before we proceed this? Okay, we will give 2 examples and then we'll move and start solving. At this moment, we skipped section 1.3 because already I shared with you an announcement what we will do exactly in section 1.3. We will do it on Thursday, and there is a group project for it, right? We'll talk about it at the end of it. Okay, let's look at this initial one. It is first order, right? Y prime equals something. So this one that is here, it's what? F. Y prime equal f times y, right? Miss?
Yes.
So f is what? Y. What's x naught, Miss? 0. So we will take this f. Do we have a problem in f equal y? Does it have a certain point that doesn't exist at f? So it's continuous. Do we agree that f is continuous? Okay. And what's the derivative of f with respect to y? 1, right? So do we have problem on the constant function? Is there a place that the constant function doesn't exist? So also it's continuous. What can we deduce? It has unique solution. Okay, Miss? Does it make sense?
I need to load the original
Function with respect to, yes. So if I have the function ey, I will differentiate with respect to what? With respect to. What I need to do is think about this one. This one is the same as writing it as y prime equal x radical 1 and is equal to 0. So the first step, determine your f, determine your x naught, and check if it has unique solution or not. What's X node, Miss here? You got the 0 from here or from here? The left. Integrate or differentiate. I'm not saying solve. Does it have unique solution or not?
You need that.
Yeah, what's up? So is it continuous? Where do we have problems in it? Negative, less than 0. Okay, so it means that when it's less than 0, I cannot check its unique or not, right? So still I have to check parts that is possible. What's then? What should I find after F? F is enough to determine? Fy. Find Fy. Thomas, do all of us agree that F is equal to X radical Y? Where is it continuous? What? Y greater than 0. Do we agree? Y greater than or equal to 0? Because at 0 also I don't have problem. But if it's less than 0, do you have problem? Is this one enough? What should I do? Apple. Okay. Yeah. Where's our apple? The X or the radical Y? Why? Because we are differentiating with respect to what? To what? The apple, is it alone or multiplied by something? So copy it again. What should I put here? X. Derivative of radical Y, we wrote it last lecture on the table of integration. What's the derivative of radical Y? 1 over 2 radical Y. So this one is continuous oneness. We have a problem that Y should not be negative, right? But also here Y is down, so it should not be 0. So this one is continuous for what? Y greater than 0. Any questions so far, miss?
Yes.
Question?
No.
Okay. What's the common between these ones?
Better.
Greater than 0. So what can we deduce? If it's strictly greater than 0, we have here these two conditions. The common between them is Y greater than 0. So because both of them are continuous with Y greater than 0, it means that, what does it mean, miss? Can we say that the solution exists in any interval one that is greater than 0? But where's our problem? The X node. If the interval is greater than 0, 0 doesn't belong to it. So can I say that it has unique solution?
No.
I cannot determine that it has a unique solution. Okay? Okay, what if we wrote it in this way, miss? Do we have now a problem? Why? Because X node now is what? It has unique solution. Like, I don't have problem in this 0. So again, when we want to determine whether it has a unique solution or not, the first step, what do we need to do? Determine your F, determine your X node. F, is it continuous over an interval containing 0? Find Fy then. Is it continuous over an interval containing X node? It will be unique solution. Otherwise, we cannot determine. Let's say I'm putting y is 5 equal -1. Do we have problem in it? 5, does it have problem? Our only problem is 0 or less than 0. So if the given is 0 or less than 0, we cannot determine. But if it's greater than 0, I'm okay with it. It's continuous and it's partial derivative continuous, so it has unique solution. Okay, miss? Go back now. So our main objective, they were to demonstrate understanding in initial value problems. We know what's meant by initial value problems. How do we find the solution of an initial value problem given the solution of the differential equation, and identify when a first order initial value problem that has a unique solution or we cannot determine. Do we have any question about this one, Miss? Miss, again, we did not finish yet chapter 1. We still have one section, which is about models. And we said that this section we will do it on Thursday as group work. We'll start with chapter 2. First of all, chapter 1 was introduction to differential equation. To understand what's meant by differential equation, the importance of it, that you will explain it to me hopefully on Thursday. Initial value problem, what do you mean by unique solution or non-unique solution? Now, the next step is, what's our aim? Solve, right? So how will we move now? Chapter 2, it will be related just to first order differential equations. We will learn different methods to solve differential equations that they are first. After we finish chapter 2, we will move to higher order. Okay, miss? So in this chapter, the only differential equations that we are concerned about, they are what? First order. This chapter, it will remind us of the tools of integration. You learn first of all substitution, then substitution, it doesn't work for all, so you learn integration by parts and so on. So here we see, we'll start with separable. After separable, we'll go to linear. After linear, we'll go to exact, Bernoulli, and substitution. In order to understand this lecture, miss, we need basic integration formulas, and we will write them together on the board. We are still in the same learning outcome, and our objective is to identify and solve a separable equation. Before we go deeper, miss, what do we mean by separable? From its name, from English point of view, what's separable? Separate, perfect. Okay, think about a function. The functions that we are dealing with, they contain x and y. So what do you think? How will I separate this function?
Separate x by y.
Okay. Does it make sense? So first of all, we will define what's meant by separable function. It means that x and y, I can separate them. After that, we will talk about the method of separation in differential function. Have a function. This function is an x and y. We need to separate it. Is it separable? To be separable, we should write x alone multiplied by something in y alone. Let's give an example. If I have x times y squared, is it separable? X, y squared, separable or not? I'm able to put the first in a box multiplied by another box. But if I have x plus y, am I able to separate them by product? Not every function is separable. In this lecture, we care just about separable function. Okay, miss? So what do you mean by separable? Separate them by product. We will put a box for things in x, box for things in y, and multiply them. Please write the definition. We have here 2 examples. We will discuss them. After these 2 examples, after that, I need each of you to write his own example. minus 2y. All of us agree that we cannot separate it. Let's look at ex plus y. How can we write it?
Yes.
Ex times ey. So this one is the box in x, and this one is a box in what? So it's, please check ln x y. Is it separable?
Yes.
Separated. Okay, so is it separable? Are we able to plus? It's separable under plus, but I want it separable under multiplication. So this one is not separable because this one I can even write it as ln x plus ln. Okay, I cannot separate it. Let's look at ex y squared.
Yes.
Separable, right?
Yes.
This is something in x, and this is something
Y.
in y. So this one is separable. Let's check homogeneous. Let's check tangent x over y cubed. Is it separable?
Yeah.
How do we write it?
Yeah.
So tangent x alone and 1 y cubed alone. Box times box in x times another box in y. So it is separable. Okay, did you understand what we mean by separable? Can you do your own example about separable and share it with your colleague? Okay, so you chose 25xy, 25x alone and y alone. This is separate. Shams, what did you choose? Box for x, box for y alone. Okay, we can think about it in this way. A box in x times another box in y. So for example, the box in x, I want it to be x squared plus 2. The box in y, I want it to be tangent y squared plus 1. And I'm multiplying them together. Okay, so separable. Function in x only multiplied by function in y. What did we choose here, Smile? Okay, so ln x times cotangent y. Radical x sine y.
Negative x, y for one.
Okay, so all of these are separable. Abdul Aziz, what did we choose?
Skip one targets.
No? Okay. Till now, I cannot tell you why I'm separating. I'm just telling you what's separable. And the next step, we'll know why do we have to separate. So here we are just asking, is it separable or it's not separable? So give me an example of separable. X times y, the easiest one. X in a box, y in a box. Shams, now, are we able to give an example of separable? Yes. Draw 2 boxes in front of you. Put in the first box something in X. Second box something in Y.
X1.
Okay. What you wrote now, do you multiply them together? Okay. So X times Y squared you wrote. Did we get it now? This function in X and Y, you are putting a box for X, box of Y, so it's parallel. Here, are we able to put a box of X, box of Y multiplied together? x minus 2y. Are we able to put a box for x and box for y? Yes, how? Put it for me. And the minus. Okay, so we have three boxes. I have box for x, box for y, and box for the sum. In this case, we find this product. Product is accepted. Minus is not. We get it? Sorry. Okay, so this is what we mean by separable. I was asking, okay, why do I need it to be separable? So now the next step, we need to talk about first order differential equation. To be separable, any first order differential equation, we are able to write this in this way, right? Y prime equals something. So to be separable, the function, it should be separable. Okay, how can it help us? So I'm saying now y prime is equal g of x times h of y, right, miss? If it's separable, I'm separating it as box in x and box in y. Y prime, how can we write it, miss? dy by dx, right? So copy the right hand side. G of x, h of y. Now everything in y, we want it on a side. Everything in x on another side. So y and dy on a side, x and dx on another side. Can we do it?
dy over
Can we do cross multiplication first? What will we get, miss?
dy.
dy over hy equal g of x dx. So we separate them, x alone and y alone. Because of that, we call it separate. What's our aim, miss, at the very end? To solve for what? To find what? Y, right? Okay. Yes.
For one there.
This one is separable.
Let's.
So we call it as you are separating it into two functions.
So you give it that.
Yeah, I give it a name, but in reality, it will be like in your example for 2x times y squared, one of them 2x and the other is y squared. What's our aim, miss? To find what? What? How do we find y if we have dy? What should we do? Integrate. So now what should I do? Integrate both. Am I able to integrate the first part? Yes, because it contains only one. The second part, are we able to integrate it, miss? The second part, are we able to integrate it? It contains what?
Yes.
The x and x. Okay, so the main thing in this one is to separate, integrate. So all what we need here is just tools about integration. Okay, miss? If you want to take some notes, take them. After taking the notes, I need from each of you to write the table of integration in front of you. Or try to remember the integral of specific functions that we took in calculus 1 or calculus. What I need from each of you to do now is complete this table. Here we have a, and here we have integration of a. So we need first the integral of 0, integral of x, and here n is not negative 1. We need 1 over x. We need ax sine ax sine ax. Please write it down and try to complete it. What's the integral of zero? How do we understand integrals, Miss? So when we say f dx is capital F, what does it mean? F prime is equal to what?
F.
Small f, right? So since it is the opposite of the table of derivatives, so which function the derivative of it is zero? Constant. So what's the integral of zero? And the antiderivative of it is
Yes.
and there is something here. What should I add, Miss? Plus 1/x. What's the integral of it? Length, absolute x, and always we add the constant. EAX, A is a constant, of course. 1/a, EAX plus B. If we have only EX, it becomes EX. Sine AX, Miss. So sine and cosine, we alternate them, right? What should we put? And for sine, what would we put? Minus. This one, the cosine, it becomes. And we have just sine x, it becomes negative cosine x. So the A here is considered as well. Do we have any question? Now, in case there is a rule that we need it, we'll write it again. We will add it to our table. Do we have any questions? Did we finish writing from the board? Okay, let's start with our own example. I want you to solve y prime equal EX plus 2. First, we need to check if it's separable, right? This EX, how can we write it? So y prime is equal EX times E21. Do we agree? So is it separable?
Yes.
Separable. Please do not write. Just we need to understand this example. I will give you time to write it and then to think about another example. So till now, all of us agree that it's separable. Now this y prime, how will we write it? dy by dx is equal ex e2. Everything in x on a side, everything in y on another side, right? This one, e2y will go to the other side, right? And dx will come to this side. Are we okay with it now? Okay, we try to simplify it as much as possible before we integrate. Now, e2y is down. Please let me know if I can write it as e negative 2y d1. Can we?
Yes.
Okay, which rule did we use here, Miss? 1 over EA is equal e negative a. So we put it off. And this one, it stays the same. This one is the simplest form. When we reach the simplest form, what do we do, Miss? So integrate both sides, write it down, and think about integrating it. So this one will explain it in detail. Then we will give an example. We will do it in pairs, and I will be taking attendance during this time. We reached this one. Now the next step, what do we need to do? So we will do integrate both sides. I'm writing from the board, miss. Okay. So what will we get when we want to integrate this? We will get e minus 2y dy equal e at dx. This step, are you okay with it? We need to integrate now. This one from the table of integration is ex, right?
Yes.
Plus constant. And this one from the table of integration, let's go back to it. Let's say, so how should I write it, miss? Negative e minus. I did not put the constant. Why? We have constant on the left, constant on the right. I can just write it as one constant. Right, miss? Constant minus constant is another constant. Now, the constant, usually we put it on which side? X. With X. If you want to put it with Y, it's okay. Okay, miss? So how many constants do we need here? One constant, usually we put it at X. We reach this one, miss. This one is acceptable if I'm just asking you to solve. This one, we reach an implicit solution, right? But if I'm asking you find explicit solution, it means that write y in terms of x. What do we need to do? So besides this one, we will write this is implicit solution. Suppose now the question is find explicit solution. What do you mean by it? Why? So if the question is just solve, you have the right to reach the implicit solution. But if the question is find the explicit solution, we should continue this one.
We the line, we move everything to the side.
Yeah. Please write it down and think about the explicit solution. Hmm?
And then can't be.
Yeah, but it's not one. E or something is not a negative. Actually, when you put e or something, whatever it's negative or positive, it can be positive. Minus. Okay. So we need to find the explicit solution. What should we do? E minus 2y is equal negative 2 into EX plus B, right? We multiplied by negative 2. The first step, are you okay with it?
Yes.
Then what do we need? Y. How do we get rid of the E? Lim E power alpha is what?
One over. Not one.
Yeah, it was negative half. So negative half, how do you get rid of the negative half? You multiply the whole equation by negative two. Okay? Okay, so what should we do here? What's the step? What's the step, miss? Limit both sides. We will get rid of the exponential. Do we agree? What will we get now? Use this one. Minus 2y ln e, which is minus 2y, equal ln minus 2 e x plus. Okay? So what will be y? This one, what do we consider it? Explicit solution. Okay, miss? Now you will tell me I cannot have negative inside the limit. Yes, you cannot have. But negative x, it doesn't mean that it's always negative, right? So it means that this part that is here negative times negative, we will get it as positive. Remember that here we have to see. So it makes it as positive. Do we have any questions, miss? Again, if I'm just asking to solve, do not find the explicit solution. Don't waste your time on the explicit solution if you are just asking for solution.
What is the solution?
This one we call it explicit. The first one we call it as solution. Usually, always we try to find the implicit solution unless we are asked to find the explicit solution. Because the explicit solution, it needs like 2 more minutes to finish the question. Any questions, miss, regarding our first example? Now, I need from you, each of you, to choose his partner and solve, and we will write an example on the board and you will solve it together. Okay, miss? Please choose your partner. During this time, I will take a step. Guys, it doesn't mean that always the differential equation will be given it as y prime equals something. Here they are writing the dy and dx, and it's easier for us. I will just put the dy on the side and dx on our side. Start with it, miss, and while you are doing it, I will take it. Also reach the explicit solution as well.
Different explicit or just
Explicit. نور الهرمسي، عبد العزيز الشمسير، عبد الرحمن العامري، مؤيد، لؤي سليمان، لؤي سليمان، سلطان،
Yes.
عبد الله اسماعيل، إرشاد أسير، إسماعيل هير، أبو زيد هير، عمر هير، جوني هير، علي هير، أحمد إسماعيل. Okay. So it doesn't mean that it should be written as y prime equals something, right? So what's the first step? Move, separate y is alone and x alone. Did we do the steplet?
Yes.
So this step, we started with this step, right? All of us did this one then? Then dy, bring y to the part of dy, x to the part of dx. We reached this one now. What's the next step? Integrate both sides. The constant, we put it on one side. You want to put it on the side of x, put it on the side of y, also feel free to. What's the integral of dy by y? Ln absolute y. And the second one, minus ln 1 plus x. Okay, this one, what do we call the solution? Where is it?
Minus.
Really good one.
Minus dx over 1 plus x.
Here I don't 6 plus. Okay, because we don't have minus anyways. Okay, so we got here implicit solution. How do we get rid of e less of ln? E ln alpha is equal to what? To alpha, right? So what should we do here? E both sides. E both sides. Yes, what's your question, Maria? Which part we did not do it?
Actually, I'm going to see this.
Not this one. 1 plus x dy equal y dx. We have this one, okay? Just the minus sent into the other side. Now collect the y's together. dy over y is equal dx over 1 plus x. Can we integrate now both sides, miss? Integral of dy by y ln absolute y plus constant, but we will put the constant on one side only. This one is ln 1 plus x plus constant, right? Again, this is implicit solution. If we want explicit solution, how will we find it, miss? Get rid of the ln. How do we get rid of the ln? E both sides. Mu'ayyad, is it okay now?
Yes.
So E both sides, what will we get? Y or absolute y, miss? So E ln absolute y equal E ln 1 plus x plus this one is equal to what? Absolute y, right? Miss, can I write it in this way? If we separate it, you just write it at the beginning of the lecture, okay? Now, if you don't want to separate it, it's okay. You can keep it in this way. As soon as I wrote y equals something, it means that it's explicit. So what can we deduce here? Y is equal ln 1 plus x is equal to what? Right, miss? Excellent. I will not remove it. I will remove it now the next step. Till now, is it okay, miss?
You want to move the fruit?
Now, at the step, no, I will remove it after. Till now, is it okay, miss? We need to remove the absolute value. Miss, when we say absolute alpha equal beta, what does it mean? Alpha is equal to what? Plus or minus? And now, I will remove the absolute value. What will we get? Plus or minus 1 plus x e power c. Okay? And this one, we will consider it as what? Explicit solution. We wrote it y equals something, right? So this is the explicit solution. Do we have any questions, miss, about the steps? Again, we don't find the explicit solution unless we are asking you to do that. Unless it's clear that find the explicit solution.
You need to write the.
The idea is that you can remove them. How can I remove them? If you keep it till now, it's correct. I can remove them with this one and it costs normal constant. But if you keep it in space, any questions, miss, before we proceed? Do we have questions? Yes, Mu'ayyad.
Okay.
You're okay with it now?
Yeah.
Ahmad. So it's just integrating, collecting y alone and x alone. And that if one takes explicit, write y explicitly in terms of x. If you can go through the solution in front of you, and if you have questions, you may ask. If not, we can move to the next exercise. Please write this question. What's the difference between this question and the previous questions? Previous one, did we have? What do we have?
Have exponential value.
We have initial
Value.
value problem. So this one is an initial value problem. Anyways, to solve an initial value problem, what should we solve first? The differential equation. Then we find the value first. Okay, miss? Please write the question. We will do it in details, and then I will give you another initial value problem to solve it in person. Here we are not asking for the explicit solution. So I will solve it without reaching the explicit solution. What's the first statement? Y prime. Instead of it, what should we write?
Y with X.
So dy by dx is at into 1 plus 5. Collect the y's together with dy and the x together with dx. عبد العزيز. Collect this. What will we get, عبد العزيز? 1 plus y squared, it becomes down, right? Right, miss? Okay, dx, bring it to the other side. What will we get? 2x. It's the simplest form. When we reach the simplest form, what should we do, Ahmad? What should we do when we reach the simplest form?
Integrate.
Integrate. So we will put here, integrate both sides. Now from calculus 2, dx or du over du over a square u square is equal 1 over a tangent inverse u. Writing it, miss. Now, in case we did not solve any example on the board, let's say related to one of these integrals, I will put it as hint. But because now I mentioned it in class, so I have the right to bring a question about it. Now, what I need from you to do is to use this formula to do this one. So we need to integrate this one. What's the integral of this method? Yes, tangent inverse y because a is 1. And the right hand side, what's the integral of 2x? X square almost plus constant. We reach this one. This one, what do we call it? Implicit solution. Suppose that I want to find the explicit solution. How do I find that? Tangent both sides. So when we want to get rid of the inverse, multiply by apply the function by itself. But this one we can consider it as implicit solution. Yes. Are we done this? Are we asked here just to solve the differential equation, or there is something extra here? What do we have? Initial value. So when we have initial value, what should we find? We have this initial value. So what should we find?
C.
So find C. Okay. So how do I find C? Did we finish writing this? Are you okay before we move forward?
Yes.
What do we have here? Tangent inverse y is equal to x squared plus. What do we have, miss? Y at 0 is equal to 1. What does this one mean? So instead of x, we'll substitute 0, and instead of y, we'll substitute 1. Tangent. So tangent inverse 1 is equal to 0 squared. It means that t is equal. Which angle the tangent of it is 1? C is pi by 4, right? What's tangent pi by 4? Tangent 45 is 1, right? But we write it in 5. So how can we write now our answers? Tangent y inverse y is equal x squared plus, instead of Siemens,
5 over
5 over 4. This one, what do we consider it? Implicit solution. Okay, ma'am? If you're okay with it, find now the explicit solution.
We have something like, this, for those in favor.
Any questions for Farman? Abdulaziz's questions?
No.
Muayyad? Dirsha? Okay. Now, miss, if you want the explicit solution, we should write it as what? What should we do here?
And
Why did you use the tangent and not the sine? Because when we have tangent inverse. If I have sine inverse, I will say sine both sides. Cosine inverse, we sine both sides. So what will we get now? Y is equal to tangent x squared plus 5/4. And this will be our final answer, which is our explicit solution. Okay, and again, we don't find the explicit solution unless I'm asking you to do that, because sometimes it's very difficult to find the explicit solution, and sometimes we cannot find the explicit solution. Usually, if it doesn't require lots of steps, I ask for the explicit solution. Like this one, it requires one step. The previous one required only 2 steps. Do we have any questions, please? Okay. So before we move forward, and I will give you, I will assign some questions to solve alone. Let's recap. So what do you mean by separable, Ahmed, now? 2 boxes, box times another box in X times box on N1.
Right.
What's the method of separation? We put dy and y alone, dx and x alone, then what do we say? Integrate. When we are integrating, we have constant of integration, but it's enough to put it on one side only, and usually we put it with x. Integrate. Once we integrate it, we will get implicit solution. Do we continue? Depending on the question, right? Find explicit, continue. Just how reach this one. Do I need always to find the constant c? Unless it's what? Like this example, unless it is an initial value problem. So if you look here, this one is an initial value problem. What I need from you to do, if you want to work it out alone, it's okay. If you want to work it out afterwards, please, or as. So this one is initial value problem. It means that we need to find the constants.
We need to put the y in the side.
Of course, the first step, find was, yes. I actually start with it. Shams, do it with Noor. Noor, can you do it with Shams? Abdullah, do it with Ismail or do it alone? Yes, we need to practice in class. We know that after like 1 week or 10 days, we'll start with Ramadan. So if before Ramadan we're sleeping, in Ramadan, what will we do, miss? Plus, miss, again, our examination will be in Ramadan. We don't have another option. So if you're planning to travel or whatever, try to do it during the break. Already we have 3 weeks break, no need to take more, right? Much 3 weeks break, right? Don't you get bored?
What's called the white line, but the white line, what?
Why prime? Write it at dy by dx. You're done? No.
This is not the white line, it's not white line.
Why, miss? I'm not here, right? This is the color.
I thought this is white line.
No, come on. So this one, y prime equal negative x over y. This is what we do by.
This is an announcement.
Now it makes sense.
Integral of y square root. Who's done? Yeah, it should be plus for me, honestly. In case you're saying. Yeah. Okay. So let's keep it developed. So that way it's function. So keep it this way and now find GC. Okay, Ms. No need to find the explicit solution. It's perfect. So you found that. Now try to see. How will you find the yes, why for people? Yes, we no, not explicit. It's you need to find it because we want to. Okay, so I'm asking for 4 y for it. Yes. Minus x is minus x square root. And y is y square root. No, it depends here. What's x? What's the x that I would choose? We don't have option. And this would be what? So here, you found the extra solution. Why did you take constant? Plus 3. Okay, now find C. You found it? Is it 0? Okay, so keep it if you did not calculate it, right? So Miss, almost all of you started it correctly. Dy by dx is equal negative x over y. So y alone and x alone. The first step, please let me know if you did it correctly. What can we say here? Y dy equal negative x dx, right? This step, are you okay with it?
Yes, no, it's not good. I'm from Saudi.
How to do what? How to flip it? Usually cross multiplication. Now integrate. What's the integral of y after that, please?
Why?
Y squared minus x. From where did you bring it? Table of integration. Always go backward. Okay. This solution is accepted as implicit solution. But is it enough at this moment? Why, miss? Why should we find it? Because we are given an initial value. Okay, so till this step, are you okay with it, miss? Now, what's the next step? Our aim is to find C. From where should we find it? Y4 equal -3. What does it mean? Substitute x equal 4 and substitute instead of y. Minus. Okay. Where should we substitute? Here in this equation. Are you okay with it, miss? Okay, let's continue. So y square over 2 minus 3 square over 2 equal minus x square. So 9 over 2 equal minus 16 over 2 plus constant. Constant, it will be 9 over 2 minus 16 will bring it to the other side. So we will get 25 over 2. Right, miss? Did all of us get it in this way? So what will be the answer now? The final answer, it will be miss y squared over 2 equal minus x squared over 2 plus 25 over 2. This is implicit solution. You need to write it in a better form. We can do that. Multiply by 2. Okay. Miss, this is optional. Optional to continue it. If you want the shape of it to be better, so it will be x squared plus y squared equal 25. But this one is also accepted. Okay, miss? I multiplied by 2 and bring x and y to us. If you want to keep it in this way, also it's correct. And this one, what do we consider as implicit or explicit? Implicit solution. So let's go back and explain it again. First of all, spread the y and dy alone, dx and dx alone, then integrate. We got constant. This constant will bring it from the initial part. Who reached the final answer? Okay, the other ones, were all of us able to reach this blue part? Okay, so just the initial value problem, we need some training on it. Okay. Any questions before we proceed? Let's get one more examples. Write this question and think about it also in the list. Did we write the question list? E2y minus y cosine x, y prime or dy dx equal ey sine 2x, and the initial condition is y at 0 is equal to 0. We wrote the question, miss? Should we use the annotation of the first one so that we don't forget? But while solving, we may use these ones. A plus B over C is the same as A over C plus B over C. The other thing that we may use is E power alpha over E power beta is E alpha minus beta. All of us did that. You put the x on the other side. Still here, what do I need to get rid? EY, where should I bring it? Okay, how do we bring it? E 2y minus 1 over EY dy. The t was sine 2x.
That was a cosine.
There was cosine here.
It's over. Cosine and the negative. Yeah.
And this one, right, Max? So the y, I will put them in blue. All of them basically on the side. And the x, I will put them in purple. All of them also should be on the side. All of us were able to do this step method.
Yes.
Okay. Sine 2x is equal. Use this one to simplify the right-hand side. You're calling someone? Please close it. So we will use this one for the right-hand side, and for the left-hand side, what will we use? The ones that we wrote here. Okay, miss? So the first one, it is, can I write it E2y over y minus y over EY dy? Please let me know. Can I write it in this way? Right? Can we write it in this E2y over EY? Can we do that, miss? And the second one, sine 2x, we will write it 2 sine x, 2 sine x. Already we have sine x, and here what do we have?
Yes.
So I'm just simplifying it to make the integration easy. If you look at the right-hand side now, it's very easy to deal with, okay? Still, I will rewrite it in a better form, miss. So what do you think about E2y over EY? Can I write it as EY? How did I get that? E2y minus y. Which formula did I use for it? E alpha minus beta. Okay, miss? And this one, can I write it as E negative y? Can we do that, miss? Okay, equal to sine x d. Now, this is the simplest form that we can do. So what should I say now? Integrate. Okay? Miss, you can ask for integrating both sides before you simplify, and then you simplify after it. So this one, how did we get it, miss? E2y minus 1. Okay, we reached this one now. What I need from you to do is to integrate. Now the next step, integrate both sides, right? EY minus y e negative y dy is equal to 2 sine x dx. This part is equal to what? What's the integral of this one? We start with the easiest. For me, this one is easier. So this one is negative 2 cosine x plus, right? The first one was, can we write it as integral ey dy minus rightness? Which part do we know here? This one, the integral of it is. Now this one, I will call it as I, and I will evaluate it alone because this one is not on the table of integration. Right, miss? So if you look here, miss, I cannot answer the whole question in one step. I should break it into parts. Suppose that I wasn't able to integrate this one, it's okay. I will take points on this, points on this, points on everything, and only this part will be missing. So if I miss this part, out of 5 points, I will lose like maximum 1 point. But if I did not start at all, I will lose the 0. I will lose all the points, right? Please write it down and think about this integral now. And this usually just differs. This chapter, it requires integration. The other chapters will move to exam 2 and the final. They don't require lots of integration. But this part, it requires integration. Because of that, always we are putting the formulas, but we need to practice. Any questions so far? Did we finish writing from the board? I, y, e, negative y, ey, and our aim is to integrate. Okay. Now this one we will go back to calculus 2. I'm not sure if you learned this method in calculus 2. You learned integration by parts, right? So this one I can use integration by parts for it. But there is an easier way. Most of us took it in high school, which is the American method or tabular integration. Have we heard about it before? Table.
Derive each one.
No, table we do it. Okay, anyways, I will explain. So here, what do we have? This one is a polynomial, and this one is exponential. Right? Usually we use this one when we have polynomial, and on this side we have sine or cosine or exponential. This method we use it. What do we do here? We do here derivatives.
Doctor, that is monomial.
Polynomial is like x
Poly-
squared plus 1.
Polynomial means more than one. Monomial, you know. So this one is monomial. I took it in high school, I don't know. You can double check.
Polynomial.
You can double check it.
I don't know how they explain for you the monomial, but this is a polynomial. It can be maybe monomial according to this one, but it is also polynomial. Okay, so this one polynomial of degree 1. Now, here we put the derivative, we keep doing derivative till we reach what? Zeros. And each step here, what do we put in? Plus, minus, and so. Okay? This method, we call it American method or tabular integration. If you want to take notes about it, please take the notes and then we will apply it to make sure that we understand. So here we have the polynomial, and what do we have also? We have the exponential. After that, you can search for polynomial of degree 1. Example of polynomial of degree 1, and you will find that this is a polynomial of degree 1, and we can call it as well polynomial. So what do we need to integrate? This is the polynomial here. And this is what? The exponential, right? What's the first derivative of 1? 1. The derivative of 1? 0. And we stopped at 0. So if I started at y squared, I will go for 2y, then 2, then 0. Then integral now. Integral of e negative y. What's the integral of e negative y? Minus e minus y. And integral of minus e minus y is e minus y. And then what do we put? Plus, minus. Okay, Miss, if you don't want to use tabular integration, it's okay. Use integration by parts.
So now that we step like that.
Yeah, now I will continue in this, but till this moment is okay for you. Now, what's the next step, Muayyan? I is y times negative, and the second one minus. You will get this, okay? Then the last step, this I that is here, you will go to here and substitute it. Okay, so the last statement, we will go to this part that is here and substitute our I. Okay, miss? We need to go to this part and substitute our I. So what will we get, miss? EY minus Y. This is the left-hand side, and the right-hand side is what? And this one, what do we call it? Implicit or explicit solution? Implicit solution. Okay, miss? Do we have questions? Now, just to make sure that we understood the tabular integration, what we will do after you finish writing, I will put a question for those whose first time they see tabular integration. You will do it, we will discuss it, and then we will. This we have also one idea from calculus 2. It's about partial fraction. So this one you will check it alone at home, and if you have questions or during our practice session, we can do it. No, because I prepare that we will also learn the linear, so I will do it on Wednesday.
Wonderful.
No, next one.
So still have to do the issue, but
You can continue. Okay, do we have any questions so far? Now, what I need from you to do is I need from you to integrate x squared minus 3 times sin x dx. While you are practicing this one, we said that next lecture, hopefully, we will discuss section 1.3, and I told you that you will divide each yourselves into groups out of 3, and you will prepare one of the models in order to explain it in class. Already I shared with you the book if you want to go to section 1.3 and do it. If the models that they are in the book you feel that you're not okay with, you can search for other models, browse Google or browse any of the other books or resources for other model, and we need to explain it. The model, did you check section 1.3? You have to check. So please, first divide yourselves into 3, group out of 3, choose one of the models, try to start with it so that during the lecture you will be able to finalize it, because you will have only 20 minutes to do it in class, and then we will present it. Okay, this one, who started with it, those who did not take it before, are they okay? How will we divide it, Miss? This one is the polynomial, and this one is the other part. What's the derivative of x squared minus 3? 2x. Do we need to differentiate more? What will we get?
2.
And then 0. So here, what are we doing for the first column? Derivative. Now, the other column, what should we do for it? antiderivative or integration. Sine x, the integral of it, minus the sine x, the integral of it, minus sine x, and minus sine x, the integral of it, sine x. Filling the table, are we okay with it, miss?
Yes.
Then what's the next step? What's the next step? Plus, minus, and then plus, right? Write your answer now. Let's write our answers first. Okay, write the final answer if you want to call this one J, let's say. Regarding what we will do already, I shared on Blackboard section 1.3 the ideas and what we will do. So it's certain things that we need to do. But because some of the models, let's say, you may not like them, so you can choose from other resources, other models. Okay, now what's the last step, miss? J is square minus 3 multiplied by minus sine x, right? Minus 2x multiplied by minus sine x plus 2 multiplied by sine x, and always we have a constant of integration. Yes, just okay. So during this lecture, what we did exactly is that we discussed what's meant by separable function, and we used it to solve separable differential equation. Are all differential equation, can we solve all differential equation using separation? What if it's not separable? Can I use separation?
No.
So we should learn other methods as well. Okay, miss? What I need from you to do, there is one idea from calculus 2 that is covered in example 3. This one we can try to solve it at home. And I will highlight some things here to solve. So let's choose something from here. Maybe we can try this one. Okay, this one. No, not this one. So let's try this one. This one is also good. Okay, this one contains cosecant, so we can remember the things about cosecant. Yes. These ones are initial value problems, so let's choose one of them. This one and this one. I will share the PDF file. Famous? And anyways, regarding the group project, if you want more time, we can do it next week. It's okay. So if you want, we can postpone it for next week and do it. Because you will be knowing more each other and you will be able like to do the work together as groups. Okay? Yeah, just like choose your see you hopefully on Thursday. On yes, yes.
I agree.
So,
Something is not.
This should be. This should go. Before we are, so
The presentation may not be like formal presentation as we used to do. It can be just discussion. Together. It's better like you do it as PowerPoint because that you will send it to me, PowerPoint or Word or something, better than writing it by hand because you will have figures for you with that. So I will like extend the deadline for it. You can submit it on Monday. You're fine. And in case you are encountering any questions, you may ask me about.
Issues.
Presentation work could be in the way of discussion in class. Okay, let's see. Do we have any questions before we end our meeting?
You said the submission is. The problem itself.